So how can you tell if a movie is good just by reading the text of a review? For humans, it might be easy. Machines, it's slightly harder. So here's what we built: sentiment analysis visualizer for reading the text of movie reviews. Um, Machines or algorithms might be good at certain things. Like if you wanted to do this old-fashioned way, you can just look for specific words like good time, it's awfully written, it's bored, and you can get a general idea. This starts breaking down when you get to, for instance, metaphors and stuff. And that's why we use machine learning and natural language processing. So let's say I try something a little harder, like it was as smooth as sandpaper. And yes, it correctly guessed that this is a negative review. So what we basically did is we took this data set of 50,000 movie reviews from IMDb. This was found on Kaggle. And we had a bunch of text for different movie reviews and the label. Was it a positive or negative sentiment? Based on that, I cleaned up the data. I'll show you how that was done later. And we used 3 different classification methods, each a different type of machine learning. This was actually a class project from our application machine learning class in 4th year. I did this with Pranav and Reed, and I kind of just spent some time fixing it up after. So anyway, the first classification method we used is a support vector machine. This is pretty simple. So basically, when we tokenize every word from the data set, we brought it down to about 200 different dimensions, if you want to call it, which is how we classify the different text. Support vector machine helps us find the difference between what's positive and what's negative. I know this only shows 2 features. We have 200, so in some higher dimensional space. We use 3 different classification methods. Support vector machine. We used nearest neighbors for another classification system with 5 neighbors and all uniform weights. And then we also tried LSTM, or long short-term memory. Similar to this, we actually had 3 specific layers for the output layer and an input layer. And what we did was we took the whole data set, first cleaned it up, split it in half, and we used half for training and half for verification. Between the 3, support vector machine usually outperformed the other 2, and that's what we use to power this thing. So if you want, I can go into the code a little bit. Yeah, let's take a look at the code. This is training.py. You can see all our imports. We use a lot of scikit-learn. Kaggle is where we get the data from. Download the natural language toolkit and stuff. Here we can see that we have 3 LSTM layers. Model, the trainer. So trainer is actually an abstract class. Get parameters, train, validation. That's all filled in by the different types of trainers. So here's the first, support vector machine. Here is nearest neighbors, and we normally do it with 5 neighbors and uniform weights. And then the long short-term memory trainer. So if we go to server.py, and then this is the actual Python server. Here we have our own text cleaning, because you have to clean it up and tokenize it and remove all the extra words, punctuation, lowercase everything, all that stuff. Here, and then it loads the pipelines, and then it uses whatever method you pick the next word and stuff. Predict whether it's positive or negative. Beyond that, we just have more front-end stuff. So yeah, this is the sentiment analysis. We use 3 different forms of machine learning. This is my first time playing with natural language processing from class. And yeah, Anthropic, if you're watching, please hire me.